Welcome to the 2017 edition of the National Science and Math Quiz. Today we bring you the sixth... Pardon? Pardon? I'm going to start from the top. Welcome to the 2017 edition of the National Science and Math Quiz. Today we bring you the sixth quarterfinal contest, which features Aggrey Memorial Senior High School, Anlo Senior High School, and Mfantsipim School. Let's meet the contestants. Aggrey Memorial Senior High School. Aggrey Memorial Senior High School is represented by
Samuel Hagan, final year.
Ebenezer Mason, final year.
You're welcome, gentlemen.
Thank you, madam.
How are you doing?
You are very great.
What does it feel like to be in the quarterfinals?
It feels good. It feels good.
It feels very good. Okay, I can assure you that it feels better even more if you keep going up. So, what shall we expect today?
Message is, with Christ in our vessel, we'll smile at the storm.
Best wishes. Mfantsipim School. Mfantsipim School is represented by
Asari Isaac, final year.
Darrell Thompson, final year.
You're welcome, gentlemen.
Thank you very much.
How are you?
We are fine,
Thank you.
Good. Gentlemen, I need to ask, have you recovered from that terrible tie break?
All we'll say is, all is well, and God knew why He sent us to a tie break, so that His glory will be seen in our lives.
I see. Expectations for today. I'm hoping that the Lord does not send a tie break. I really dislike those things. So expectations.
The grace of God is sufficient, and the zeal of the Lord shall accomplish it.
All right. Best wishes. Anlo Senior High School. Anlo Senior High School is represented by
Fiaonu Nobel, final year.
Samuel Daniel, final year.
You're welcome, gentlemen.
Thank you.
How are you doing?
We are doing good.
Wonderful. We are in the quarterfinals. What does that feel like?
It feels really great.
Great.
Yeah.
It's greater even more as you move forward. So expectations for today.
Yeah, with God, all things are possible, as I believe. And we know that horses and chariots are prepared for battle, but victory cometh from the Lord.
All right. Best wishes to you.
Thank you.
We've met the contestants. We've met them. Everyone wants to feel what it's like at the semifinals. We'll find out soon enough. But, Anlo, if I were to count how many times I've heard the horses and chariots, 1,000 times. Anyway, we shall find out. Before I sit down, I would like to acknowledge that the National Science and Math Quiz is sponsored by the Ghana Education Service through the Conference of Heads of Assisted Secondary Schools. We also have support from TIGO, GOIL, Prudential Life Insurance, Accra College of Medicine, and GCB Bank. We are produced by Prime Time. My name is Dr. Elsie Efa Kaufman. I am a senior lecturer in the Department of Biomedical Engineering, University of Ghana. I'm your quiz mistress. Contestants, the contest comes to you in 5 rounds. The first round is a round for fundamental concepts. Simple, direct questions requiring simple, direct answers from you. If you answer your major question correctly, 3 points. If the question is incorrectly answered, it becomes available to the 2 other schools. A school may ring and attempt an answer. If the answer is right, a bonus point. If the answer is incorrect, it fetches a penalty point. For questions requiring calculations, you have 30 seconds in which to present your answer. If there are no calculations, you have 10 seconds to do so. All questions are to be attempted once only. Best wishes to all of you. For the first set of questions, I have 30 seconds, and I'm going to start with you in Mfantsipim School. Your question. Find the area of a triangle with sides 10 centimeters, 6 centimeters, and an included angle of 30 degrees. Thompson.
15 centimeters squared.
Yes. Aggrey Memorial. Find the area of a kite with diagonals of length 12 centimeters and 7 centimeters. Yes, Beneza.
42 centimeters square.
You're right. Anlo. Find the area of a trapezium with parallel sides of length 7 centimeters and 5 centimeters, separated by a distance of 10 centimeters. Yes, Daniel.
60 centimeters squared.
Yes. Be as complete as possible with your answers for this set. 30 seconds. Element. Yes, Thompson.
5D2. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 3p6, 5s2, and 5d2.
One S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D2. And then the element is a member of the second set of D transition series. Aggrey Memorial. Give the electronic configuration of an element with atomic number 28 and state where in the periodic table it can be found. Ebenezer.
We have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8, and it's defined in the first transition state. It's a member of first transition state.
Series.
Yes. Listen carefully, Anlo. Give the general electronic configurations of elements in group 3 or 13 and group 5 or 15 and predict the valencies of the elements in these groups. Yes, Daniel.
The valency for elements in the group 3 is +3, and for elements in group 5 is 5, and the general configuration is MP1 for group 3 and MP3 for group 5, where n is the quantum number.
I'm giving you 1. For group 3, the general electronic configuration is NS2NP1. For group 5 is NS2NP3. Then the valencies, you were right, group 3 or 13 is +3. Group 5 or 15, we have -3, +1, +2, +3, +4, and +5. Next set, 30 seconds. Mfantsipim, express 0.080100 Pascal second in scientific notation using SI base units only. Yes, Isaac.
8.0100 times 10 exponent -2 kilogram per meter second.
Yes. Aggrey Memorial. The rest mass of a particle is 9.00 times 10 raised to the power -31 kilogram. Find the total energy of the particle when its kinetic energy is 4.00 times 10 raised to the power -14 joule. Ebenezer.
We have 5.8 times 10 to the power -14 joules.
That's incorrect for a bonus. The right answer is 1.21 times 10 raised to the power -13 joule. Anlo, the density of a lead alloy is 11,000 kilogram per meter cubed. What mass of water is displaced by a 0.55 kilogram bar of the lead alloy when dropped into a tank of water? Yes, Nobel.
5.5 kilogram.
That's incorrect for a bonus. The right answer is 0.050 kilogram. For the next set, I have a preamble to all schools. When I get to your school, I will give you a group of organisms. Classify the modes of reproduction of the organisms as viviparous, ovoviviparous, and oviparous. Did you get it? Classify the modes of reproduction of the organisms as viviparous, ovoviviparous, and oviparous. That's the preamble. Now, in Mfantsipim School, amphibians. Isaac.
Ovoviviparous.
That's incorrect. for a bonus. Yes, which of you? Samuel?
Oviparous.
Yes. With the same preamble, birds. Ebenezer?
Viviparous. Viviparous.
No, that's incorrect. Who rang? Yes, go ahead.
Oviparous.
Yes. Anlo? Reptiles. Yes, Nobel.
Ovoviviparous.
No. Yes, that, Thompson.
Oviparous.
Yes. Next set, 30 seconds, preamble. Your major question. Actually, the preamble is very short. Evaluate, that's the preamble. Now your question. Sine of 47 degrees multiplied by cosine of 13 degrees plus cosine of 47 degrees multiplied by sine of 13 degrees. Thompson?
√3/2.
Yes. Aggrey Memorial. With the same preamble. Cosine of 83 degrees multiplied by cosine of 38 degrees plus sine of 83 degrees multiplied by sine of 38 degrees. Yes, Ebenezer?
√2/2.
Yes. With the same preamble. The expression tangent of 15 degrees plus tangent of 30 degrees all over the expression 1 minus tangent of 15 degrees tangent of 30 degrees. Yes, Daniel?
1.
That's right. Mfantsipim. Isotopes of an element tend to have the same chemical properties. But for the element hydrogen, the isotopes hydrogen and deuterium, the chemical properties are significantly different. What could be the reason for this observation? Yes, Thompson.
Isotopes, first of all, are species which have the same atomic number but different mass number due to the difference in the number of neutrons. Most isotopes have the same chemical properties. This is because they have the same number of electrons, but the hydrogen atom has a proton number of 1, and the mass number is also 1. But with deuterium, it has a proton number of 1, and the mass number is also 1. But the difference can be...
Get to the point.
The difference can be seen in the fact that hydrogen as an element can exist in both group 1 and group 7. It's also...
I'm not accepting it for a bonus. It's a simple answer. I asked you for simple, direct answers to simple, direct questions. The significant differences could be attributed to the large mass ratio. So deuterium is twice as heavy as ordinary hydrogen. That's it. Aggrey Memorial. The atomic radius of hydrogen is 0.037 nanometers, whereas the ionic radius of the hydride ion is about 0.145 nanometers, about 3.5 times. Why this big change in size? Yes, Samuel.
Madam, please, the difference in the atomic radius is due to the fact that with the hydrogen ion, it has one outermost electron, that's 1s1, and then due to the losing of the electron, it becomes positively charged, and hence the drawing of the valence shell to the center or to the nucleus is greater, and hence the size, the atomic radius decreases as compared to the original hydrogen atom.
I'm not accepting that for a bonus. Okay. So the hydrogen, you're answering a different question. The hydrogen atom has only one electron in the 1s orbital. Additional electron to form the hydride ion results in a higher mutual repulsion between the two electrons. And that's the reason why. Anlo, why do you think the H+ ion is unable to exist on its own in water or ammonia? Yes, Daniel.
This is because the H+ has no electron in its orbital. So it attaches itself, it has to be combined with, electron has to be added to it so that it can be combined.
No. For a bonus. The H+ ion is small and therefore has a high polarizing power. Because of this, it's able to attract the electron pair on the water or ammonia molecule to form a bond. That's the reason. Next set, 30 seconds. Mfantsipim School. The density of a copper alloy is 8,000 kilogram per meter cubed. What mass of water is displaced by a 0.80 kilogram bar of the alloy when immersed in a tank of water? Yes, Thompson.
0.080 kilograms.
That's incorrect. A bonus. The right answer is 0.10 kilogram. Aggrey Memorial. Express 0.0002050 joules second in scientific notation using SI base units only. Ebenezer.
We have 2.050 times 10 to the power negative 4 kilogram meter square per second.
Yes. Anlo. The rest mass of a particle is 1.80 times 10 raised to the power negative 30 kilogram. Find the total energy of the particle when its kinetic energy is 1.20 times 10 raised to the power negative 13 joule. That's incorrect. Yes, Isaac.
2.82 times 10 exponent negative 13 joule.
Yes. What does this mean? Yes, Thompson.
The semi-conservative nature of DNA means that out of every replication, you have one strand being of the original and one strand being of the new replicated strand.
Yes. A single DNA molecule, that is one double helix, undergoes 3 rounds of replication. After the final replication is complete, how many of the DNA molecules present will not contain any part of the original template? Is your hand up, Ebenezer? Go ahead.
1.
That's incorrect. Which of you? Thompson?
2.
No. The right answer is 6. Anlo, a single DNA molecule, that is one double helix, undergoes 3 rounds of replication. After the final replication is complete, how many of the DNA molecules will be present? Yes, Noble.
8.
You are right. Next 30 seconds, and I have a preamble. Preamble to all schools. Find the scalar product of the given vectors A and B and determine if the angle between the vectors is acute or obtuse. I hope you got your preamble. Again, find the scalar product of the given vectors A and B and determine if the angle between the vectors is acute or obtuse. Now, Mfantsipim School, A is equal to 3I plus 5J, and B is equal to 5I minus 3J. Thompson.
The scalar product is 0, and the angle between them is 90 degrees. So it's perpendicular. So it's neither acute nor obtuse.
Yes. With the same preamble, A is equal to 4I minus 5J, and B is equal to 2I plus 6J. Ebenezer.
The scalar product is negative 22, and the angle between them is acute. Since the cosine of a negative number is
2
acute.
out of 3. Yes, negative 22, it's obtuse. Anlo with the same preamble. A is equal to 3I plus 2J, and B is equal to 7I minus 5J. Daniel.
The scalar product is 11, and the angle is acute.
Yes. Next set, 30 seconds, and I have a preamble to all schools. Preamble. Preamble. Consider the following bonds and their respective bond energies all in kilojoule per mole. Carbon-carbon triple bond, 837. Carbon-carbon double bond, 611. Carbon-carbon single bond, 350. Carbon-oxygen double bond, 745. Hydrogen-hydrogen single bond, 435. Carbon-hydrogen single bond, 415. Carbon-oxygen single bond, 360. And oxygen-hydrogen single bond, 140. That's the preamble. Did you get it? Again. Consider the following bonds and their respective bond energies all in kilojoule per mole. Carbon-carbon triple bond, 837. Carbon-carbon double bond, 611. Carbon-carbon single bond, 350. Carbon-oxygen double bond, 745. Hydrogen-hydrogen single bond, 435. Carbon-hydrogen single bond, 415. Carbon-oxygen single bond, 360. Oxygen-hydrogen single bond, 140. Now, Mfantsipim School. Use the given data to calculate the approximate enthalpy change for the hydrogenation of propene to propane. Yes, Thompson.
The enthalpy change is the enthalpy change is negative 456 kilojoules.
That's incorrect for a bonus. The right answer is negative 134 kilojoule. Aggrey Memorial with the same preamble. Calculate the approximate enthalpy change for hydrogenation of propane to propane. If the enthalpy of hydrogenation of propene to propane is negative 134 kilojoule per mole, comment on the relative values of these two hydrogenation reactions. For a bonus. The right answer is negative 303 kilojoule per mole. And the comment is the enthalpy change for the propane is more than twice the enthalpy change for the propene. With the same preamble, Anlo, calculate the approximate enthalpy change for the hydrogenation of propanone. If the enthalpy of hydrogenation of propene to propane is negative 134 kilojoule per mole, state any observation made in the reductions of carbon-carbon double bond and carbon-oxygen double bond. Yes, Noble.
The answer is 437 kilojoule per mole. And the observation is the carbon-carbon single bond in the propanone. The energy of that reaction is lesser than the conversion from propene to propane.
That's incorrect for a bonus. The enthalpy change is positive 265 kilojoule per mole, and the observation is that the reduction of the carbon-carbon double bond is exothermic, while that of the carbon-oxygen double bond is endothermic. Next 30 seconds. Mfantsipim School. Times the energy of the particle when its kinetic energy is 2.20 times 10 raised to the power negative 11 joule. Is your hand up, Thompson? Go ahead.
It is equal to 31.0 times 10 exponents negative 11 joules.
Okay, I'll give it to you. But tell me in proper scientific notation before I let you off the hook.
3.10 times 10 exponents negative 10 joules.
Yes, isn't that more elegant? Aggrey Memorial. Pewter, an alloy of tin, has density 7,280 kilogram per meter cubed. What mass of water is displaced by a 0.364 kilogram pewter casting when immersed in water? For a bonus, the right answer is 0.050 kilogram. Anlo, express 10.030800 Newton second in scientific notation using SI base units only. Yes, Nobel.
1.000300800 kilogram meter per second.
That's incorrect. Yes, Thompson.
1.0030800 times 10 exponent 1 kilogram meter per second.
You are right. Last set of questions with a preamble. Preamble to all schools. Describe the following as microevolution, macroevolution, or mega-evolution. Did you get your preamble? Describe the following as microevolution, macroevolution, or mega-evolution. Mfantsipim School. Evolution of chemical-resistant insect pest population. Isaac.
Macroevolution. Macroevolution.
That's incorrect. With the same preamble. Variety of beak shapes among the finches of Galapagos Island. Yes, Beneza.
Microevolution.
Yes. Anlo. Evolution of tetrapods, that is animals with 4 legs, from fishes. Noble.
Microevolution.
That's incorrect for a bonus. The right answer is mega evolution. Fish to 4 legs. This is major, it's mega. That's the end of the first round. At the end of the first round, Anlo Senior High School has 14 points. Aggrey Memorial Senior High School has 18 points. Mfantsipim School has 22 points. Four more rounds to go. Round 2. This round is also known as a speed race. The questions in the round are directed to all 3 schools simultaneously. For an opportunity to answer a question, you must ring for it. May I hear your bell, Aggrey Memorial? Yours, Mfantsipim. And yours, Anlo. If you ring and answer correctly on the first attempt, 3 points. On the second attempt, 2 points. On the third attempt, 1 point. If you attempt to answer a question and you are unable to answer correctly, you lose a precious point. For questions that require calculations, you have a maximum of 30 seconds in which you can present your answer. If there are no calculations involved, you have 10 seconds maximum. Best wishes to all three schools. First question, 30 seconds. Two very large parallel plates are 2 centimeters apart and have a potential difference of 10 volts across them. Find the magnitude of the force on a 20 nanocoulomb charge located between the plates. Which of you? Thompson.
We have 100 times 10
Next question, 10 seconds. Contrary to the assumptions of the kinetic theory, forces of attraction exist between the molecules of a real gas. State one consequence of such forces of attraction. Yes. Which of you? Daniel.
Yeah, this is because of the pressure. There is more collision between there's less collision between the particles, so it reduces the pressure.
No. The right answer, pressure is lower than it otherwise would be for an ideal gas. It's not about collisions. Saying it is that a real gas has a tendency to condense. 30 seconds. Find the change in area of a 5.0 meter squared plate made of an alloy whose linear coefficient of thermal expansion is 1.5 times 10 raised to the power negative 6 per Kelvin when the temperature of the plate changes from 5.0 degrees Celsius to 31 degrees Celsius. Yes, which of you? Thompson.
3.90 times 10 exponents, this one is there, times 10 exponents negative 3 meters squared.
That's incorrect. The right answer, 3.9 times 10 to the power negative 4 meters squared. The next set, all 30 seconds. Hydroiodic acid, HI, is slowly oxidized by oxygen to give iodine and water. Please give a balanced equation for this reaction. Yes, which of you? Noble.
We have 2HI plus half O2, giving you I2 plus H2O.
Yes. Next one. In a particular chemical reaction, 2 moles of A are converted into 3 moles of B. If the average rate of disappearance of A is given as 2.50 times 10 raised to the power negative 4 mole per decimeter cubed second, then what is the average rate of appearance of B over the same period? Which of you, Samuel?
Madam, the rate of appearance of B is 1.67 times 10 to the negative 4 mole per decimeter cube per second.
That's incorrect. Who was next? Go ahead, Mfantsipim. Thompson.
The rate of disappearance of is the rate of disappearance of B is 3.75 times 10 to the negative 4 mole per dm cube per second.
Okay. Next one. The solubility product of CaCO3 is 3.6 times 10 raised to the power negative 9 at 27 degrees Celsius. A landlocked lake in the country sits on limestone. Approximately what mass in milligram of CaCO3 may be obtained after evaporating 10 decimeter cubed of the water from the lake? Repeat.
6.0 times 10 exponent 1 milligram.
Yes. Next set, 10 seconds each. Name the two systems that control the gastrointestinal tract. Yes, which of you? Isaac.
The digestive system and the lymphatic
No,
system.
somebody else rang. It's the vascular system and the lymphatic system. Certain species of savanna grasshopper appear green during the rainy season and brown during the dry season. What is the reason for these color changes? Yes, Noble.
The color change during green seasons, during rainy seasons, the color is green because it needs to blend with the color of the environment. Because during those times, the plants grow up and they are mostly green. So to camouflage with the environment, it needs to be green. But for the dry season, the color is...
Next one. What form of nutrition is the capture and digestion of insects by a pitcher plant?
Saprophytic nutrition. Saprophytic nutrition.
No. The right answer is heterotrophic nutrition. Last set of questions, 30 seconds each. Solve the equation. Cosine of x is equal to half. Yes, Ebenezer.
S is 60 degrees.
I'm not accepting that. I continue. For the interval 0 less than x less than pi. Yes, Thompson.
The values of x are 60 degrees and 300 degrees.
You didn't wait for me to read. Go ahead.
We
Yes,
have
Noble.
60 degrees and 120 degrees.
No. The complete question is, for the interval 0 less than x less than pi, please give your answer in radians. And the answer is pi over 5 plus log of the expression x plus 2 is equal to log of 14x. Which of you? Noble.
X is equal to 3.5.
That's incorrect. Who rang next? Okay, Ebenezer.
X is equal to 2 or 5.
Continue. X is.
This is equal to positive.
Wait.
X is equal to
They
positive.
rang first. Okay, Thompson.
X is equal to 5 or X is equal to 2.
Yes. Gentlemen, you are watching for me. Oh. Last question. Find the coordinates of the vertex of the curve. Y is equal to the expression x minus 2 squared plus 3. Yes, Thompson.
2, 3.
Yes. And that's the end of the second round. At the end of the second round, Aggrey Memorial Senior High School has 15 points. Anlo Senior High School has 16 points. Mfantsipim School has 31 points. Round 3. This round has the problem of the day. The problem of the day is a single question to all 3 schools. From the time I ask you to begin, you have 3 minutes in which to present your answer. The problem of the day is worth 10 points. Let's turn over our sheets and read the problem of the day together. Problem of the day. A celestial body has a mass of 7.3 times 10 raised to the power 22 kilogram and a radius of 1.74 times 10 raised to the power 6 meters. The acceleration due to gravity on the surface of the body is 1.6 meters per second squared. A 20 kilogram probe is in a circular orbit about the celestial body at a distance of 8.5 times 10 raised to the power 5 meters above the surface of the body. A. Find the acceleration due to gravity at the location of the probe. B. Find the gravitational potential at the location of the probe. C. Find the magnitude of the body's gravitational field strength at the location of the probe. D. Determine the gravitational potential energy of the probe. And finally, E. Determine the centripetal force on the probe. Contestants, this is your problem of the day. You may now begin. Please stop writing and present your answers. Ready. Contestants, please pick up your notepads and present your answers on the boards as shown here. Hey, Anlo, you are even in a bigger hurry than me. Thank you. And it has a radius of 1.74 times 10 to the 6 meters. The acceleration due to gravity on the surface of that celestial body is 1.6 meters per second squared. Now you launch a probe. This probe has a mass of 20 kilograms, and it's in a circular orbit about the celestial body at a distance of 8.5 times 10 to the power 5 meters above the surface of the body. And there were questions to be answered. Now the thing is, if you had all the time in the world, you could do this in your own time, many different ways of doing this. But if you have 3 minutes, you better be strategic. So to help us to do the calculations, let's define some parameters. We'll let R0 be the radius of the celestial body. That's given. Then we'll let R be the position of the probe. So the position of the probe is going to be taken from the center of the celestial body. So we have the radius of the body plus the distance that we have been given above the body, right? So the sum of those two will be R. Okay, then other things are the normal, the usual parameters. So the first question was to find the acceleration due to gravity at the location of the probe. All right. The acceleration due to gravity at any position can be given by, so a position that is R away from the center of the celestial body is going to be given by the gravitational constant multiplied by the mass of the celestial body divided by the square of this R. But if you do it this way, if you start substituting values, you will take a long time to get your values. But if you recognize quickly that you can obtain the same value by taking the acceleration due to gravity on the surface of the body and then multiplying that by the square of the radius over the square of R, the position of that probe, you can get to the same answer, and it is a whole lot easier to do. So that's the path we are going to follow. So we've been told that the acceleration due to gravity on the surface is 1.6 meters per second squared. We multiply that by the square of the radius of the celestial body, that is 1.74 times 10 to the power 6 meter squared, and divide by the square of the position of the probe. So divided by 1.74 times 10 to the 6 meters plus 8.5 times 10 to the 5 meters and squared. If you do the calculation, you arrive at 0 meters per second squared. This is worth 2 points. All right. The next is to find the gravitational potential at the location of the probe. Once again, you can use the long way or the short way, but with 3 minutes, I suggest the short way. So the potential is negative G, the gravitational constant, multiplied by the mass of the celestial body over R, the position of the probe, but we are going to take a shortcut. So this is going to be negative r multiplied by the acceleration due to gravity that we have just calculated for the first part. So this gives us negative 1.7 times 10 to the power 6 plus 8.5 times 10 to the power 5 meters multiplied by what we calculated, 0.72 meters per second squared. And this should give negative 25.9 times 10 to the power 5 meters. Squared per second squared. All right, 2 more points there. C, find the magnitude of the body's gravitational field strength at the location of the probe. The magnitude of the gravitational field strength equals G at the location of the probe. So it's the same as what we have. But we need to use the proper units for gravitational field strength. So we'll have 0.72 Newton per kilogram. 2 more points. D, determine the gravitational potential energy of the probe. This is obtained by simply multiplying the potential we calculated in B by the mass of the probe. Very simple. So we have 20 kilogram multiplied by negative 1.9 times 10 to the power 6 meters squared per second squared, and this gives negative 38 megajoule. 2 more points. Finally, determine the centripetal force on the probe. Acceleration due to gravity at the position of the probe. We know both of these. So 20 kilogram multiplied by 0.72 meters per second squared, and this gives 14.4 newtons. 2 more points, giving a total of 10 points. This was the suggested solution and the expected solution to this problem. Contestants. Aggrey Memorial. I can't find anything useful to give you anything for. No. Your formula you have there for D is not the right one. And certainly for E, that is not right. On humanitarian grounds, I'm giving you 1 point. Mfantsipim School. You tried to go the long way and it wasn't working out. But you do have a formula which is reasonable for, if you had about 10 minutes, you could have done this thing. But 3 minutes was not enough for you. For having the formula, I'm giving you 1 point for A and another point for E. Those 2 formulas. That gives you 2, and then I gave these guys 1. I'm adding 1 more, 3 out of 10. Anlo, similar trouble, long way. So I can't give you anything because you couldn't complete any of them. It was the long way. But your formula for A, I'll give you 1 point for that. And then for B, I'll give you another point. And so that's 2. And then on humanitarian grounds, I gave those guys 1. I'll add 1 more to make it 3 out of 10. That's the end of the problem of the day and the end of round 3. You may pick up your notepads. Before we begin the 4th round, I would like to acknowledge that the National Science and Math Quiz is sponsored by the Ghana Education Service through the Conference of Heads of Assisted Secondary Schools. We also have support from TIGO, GOL, Prudential Life Insurance, Accra College of Medicine, and GCB Bank. We are produced by Primetime. Thank you. Round 4. In this round, I'm going to be presenting you with statements. When you receive a statement, please consider the statement carefully and let me know whether it's true or choose not to respond, in which case sulfur occurs in crude petroleum. Yes, Samuel.
False.
You're right. Hydrogen sulfide occurs in natural gas. Daniel?
False.
No, that's a true statement. The Yes, Nobel.
True.
Yes. Opposite angles of a cyclic quadrilateral are congruent. Yes, Isaac?
False.
Yes. A particle moving in a circle at constant speed is in equilibrium because its speed is constant. A particle moving in a circle at constant speed is not in equilibrium because a moving object can never be in equilibrium. Yes, Daniel?
False.
You're right. A particle moving in a circle at constant speed is in equilibrium because the centripetal force on the particle is equal and opposite to the centrifugal force on the particle, so the net force on it is 0. Isaac?
It's true.
No, it's not. A characteristic property of acids is their ability to change the color of some vegetable dyes. Ebenezer?
It's false.
No. The word acid comes from a Latin word acidus, which means bitter. Yes, Daniel?
False.
You're right. Milk turns sour when it goes off because some lactic acid is formed. Yes, Isaac?
True.
Yes. The kidney and lungs are located in the anterior half of the mammalian body cavity. Yes, Samuel?
False.
Yes. The heart and ovary are located in the anterior half of the mammalian body cavity. Daniel?
It's true.
No, that's a false statement. The heart and kidneys are located in the anterior half of the mammalian body cavity. Yes, Isaac?
False.
Yes. The equations, log of the expression x plus 3 is equal to 5, and log of x plus log of 3 is equal to 5 are equivalent. Samuel?
False.
You're right. The equations, log of the expression 2x plus 5 is equal to log of the expression x minus 2, and 2x plus 5 is equal to x minus 2 are equivalent. Yes, Daniel?
It's true.
Yes. If x raised to the power 5 is equal to 35, then x is equal to log of 35 over 5. Isaac?
False.
Yes. Last set of statements. If the heat capacity of object A equals the heat capacity of object B, then the temperature of object A changes by the same amount as the temperature of object B when the two objects absorb the same quantity of heat without phase change. Samuel?
False.
Oh, that's a true statement. If the heat capacity of object A is half the heat capacity of object B, then object A contains half the quantity of heat contained in object B when the two objects are at the same temperature. Daniel?
It's true.
Oh no. Last statement. If the heat capacity of object A is half the heat capacity of object B, then object A and object B cannot be in thermal equilibrium. Yes, Isaac?
It's false.
You're right. And that's the end of the fourth round. At the end of the fourth round, Anlo Senior High School has 26 points. Aggrey Memorial Senior High School has 26 points. Mfantsipim School has 47 points. Fifth and final round. In this round, I'm going to be reading out clues. Your objective is to solve the riddle. If you solve the riddle on the first clue, 5 points. On the second clue, 4 points. On the third or any clue thereafter, 3 points. In order to solve the riddle, you must ring for it. May I hear your bell? Aggrey Memorial. Mfantsipim. Anlo. When you ring, your answer must be ready. There are 4 riddles. I am a parameter used in the description of collision phenomena. I am a dimensionless parameter. Yes, Thompson.
Coefficient of restitution.
You're right. I read the 4th clue, 3 points. Next one. I am a surface that can be folded to form a solid. I am also a weight of goods, excluding the weight of the container. Yes, Isaac?
Net.
You're right. They solved the riddle on the second clue, 4 points. Next one. I am one of the earliest concepts related to the issue of scale. I was originally used to determine the number of animals that could graze on a segment of land without destroying it. Later, the idea was expanded to more complex populations like humans. In an environment, I may vary for different species and may change over time due to environmental conditions and living space. Isaac?
Census.
No. I'm continuing. I am the number of individuals an environment can support. Yes, Samuel.
Carrying capacity.
You are right. I was reading the 5th clue, 3 points. Last one. I come from a very humble and peaceful family. On the surface, I look peaceful. I am, however, loaded with extraordinary energy. React cellulose and nitric acid, and I am the product. With low nitrate content, I am a plaster called celluloid. With a higher nitrate content, I am explosive and therefore used as gunpowder. Who am I? Yes, Thompson.
Potassium nitrate.
No. Oh, those of you making noise, where are you? Somebody is hiding. Answer it. Anyone? Anyone? Yes. Gunpowder. The right answer is nitrocellulose. And that's the end of the 5th round. At the end of the contest, here are the final scores. Anlo Senior High School has 26 points. Aggrey Memorial Senior High School has 29 points. Mfantsipim School has 54 points. Anlo Senior High School, thank you for being here. Best wishes to you. Aggrey Memorial Senior High School, thank you for being here. Unfortunately, this was not it. All the best. Mfantsipim School, congratulations on winning the contest. Prepare well, and I look forward to seeing you in the semi-finals. Congrats. Viewers, thank you for joining us for this contest. Next time, we'll bring you the 7th quarterfinal contest, which features Wesley Girls High School, T.I. Amas Fomina, and Kumasi High, Prudential Life Insurance, Accra College of Medicine, and GCB Bank. We are produced by Prime Time. Thank you for joining us this time, and see you next time. Bye.